Hello! In this video we're going to go through Learning Target 5.2.1, and this is our very first learning target of the unit. It's on the characteristics of quadratic functions, and this new unit is all about quadratics. And so today we're going to find out the important pieces of a quadratic function. And so we're going to do quite a bit of vocab. This learning target is pretty vocab heavy. And right up at the top, I want to start with what a quadratic is. So a quadratic is a function with a degree of 2. And we really only have two choices for what it looks like. It can look like a U shape or an upside down U shape. Those are quadratics. This shape is also called a parabola. So if you hear it described as a parabola, that's what that is. So now 5.2.1 is going to ask you for these characteristics of a given quadratic. So you'll be given the graph and then asked to identify each of these things. The first is the directionality, and we only really have two choices. We have upward and we have downward. And this is really referencing where the quadratic opens. So an upward facing quadratic opens up. It has arrows that point up. And downward opens down, has arrows that point down. So you just need to figure out if it opens up or down and say that for the directionality. The next one is the vertex, and the vertex is the highest or lowest point. And so our vertex would be, if we had an upward facing one, our vertex is going to be that lowest point right at the bottom. And if we have a downward facing one, it's going to be this highest point right at the top. So think of the vertex as like the bottom of a valley or the top of a hill. Our next one is the line of symmetry, also sometimes called the axis of symmetry. Those are the same thing. And when you learn about symmetry, you learn that means that the shape or item kind of like can fold on top of itself. And so the line of symmetry is the line that cuts the parabola into two equal halves. And so for each of our shapes, if we have an upward one, it's kind of like it's this line down the middle. And if we have a downward one, again, the line right down the middle. And it's lined up, you can see like with these two pictures that I draw, the line of symmetry is directly lined up with the vertex. So you kind of like start in the vertex because that's also in the middle, and it's the line that would go down and cut it in half. Imagine folding this parabola on top of itself, and those would be even. And the next two kind of go together. The roots are also the x-intercepts and the zeros. They have lots of names, but they all mean the same thing. And these are where the parabola crosses the x-axis. So if we have a coordinate plane and we have a parabola that looks like this, then we would have 2 x-intercepts, 2 roots, because it crosses twice. And the y-intercept, we've been doing that all year with different functions, is where the parabola crosses the y-axis. And again, if we have a picture, think of it like this. You have that one time crossing the y-axis. So if you need to pause that to get all those notes down, please do so, but we are going to go through an example of what this looks like. So this is the problem that you are going to see. It says determine each of the characteristics below for the given quadratic. And we're asked for each of the definitions from above. So the first one is the directionality. We only have 2 choices, up or down, and we can see it opens down, it has arrows pointing down, and so my directionality is down. Then I need to identify if my vertex is a max or a min. And so what that means is, does your vertex, which this one already has a dot at the vertex, but we can see like either the very top or the very bottom point. This is our vertex. And this is at the very top, so it is a maximum. So if it's at the top, it's a max. If it's at the bottom, it's a min. Now we need to actually identify the vertex, like what are the coordinate points that point to that vertex. So I need to look at what this is. And remember, points are x, comma, y values. And so I want to look to see that the x value for this is -1. And the y value is 3. So my vertex is at -1, comma 3. Then our line of symmetry. I want you to go back to your notes and write something for our line of symmetry. It always needs to be written as x equals. And it's going to be a number over here. So that's the format for your line of symmetry, your axis of symmetry, is always x equals a number. And that number is the x value where you would fold it in half. So what I like to do is I like to actually draw in, I start at my vertex, and I draw in like a dotted line to see where my line of symmetry is. So you can see like that's where I would fold it, and it would look exactly the same on either side. And this x value is -1. So when you draw in the line, you'll draw right through the number you want. You can also see that it is the x value for your vertex. And that makes sense because your line of symmetry is always going to go directly through your vertex, and so the x values need to be the same. So our line of symmetry is x equals -1. You do need that x equals part or it will be wrong. So in our intercepts, we probably have the most familiarity with identifying these from when we did this with linear functions. Our x-intercepts are where they cross the x-axis, and we could have none of these or 1 or 2. So in our case, we have 2 of them. And if they are not on even corners, you need to estimate a decimal. So this one is pretty close to -3, but not quite there. So I would say like -2.8 or -2.9, comma 0. So that's one of them. And with all decimals, you're just estimating. So if I say -2.8 and you say -2.9 or -2.7 or something, that's fine. It just needs to be close. And then this one is not quite to 1 yet. This is 1. And so, again, I'm going to say like 0.8 for my other one. So now last one, y-intercept is where we cross the y-axis, and this is at 0, comma 2. For my y-intercept. And these are all of my characteristics for quadratics.